All right, so in this part of our unit, we are moving on to our last type of transformation. Before we learned about reflections, translations, and rotations, we called these transformations rigid transformations. So these are rigid. The last type we are going to learn about is called a non-rigid transformation, and that's a dilation. So this is going to be our last type. So we are looking at Michael taking a photo and enlarging it so that it stays proportional to a larger photo. And so we're going to specifically look at the triangle OAB, so this part of the picture, compared to the triangle OCD, this half of the picture. And so what type of transformation? It is a dilation because the shape changes in size. So anytime a shape changes in size, we call it a dilation, and it's a non-rigid transformation. So they want us to find segment OA. So segment OA is this one right here, and that's 2 centimeters, or 2 units rather. So OA is 2 units. And if we compare that with AB is the other side of the triangle. AB is 3 units. And then if we look at OC, actually let me do OC in red, because OC is corresponding to OA. And so OC is 1, 2, 3, 4 units long. And then the corresponding side for AB is segment CD, which is 1, 2, 3, 4, 5, 6 units long. So CD is 6 units. So what do we notice about the corresponding sides? Well, from 3 to 6, we multiplied by 2. It's 2 times bigger. And same thing here, from 2 to 4, we multiplied by 2. So the corresponding sides are twice as big. So now they want us to compare the coordinates. So let's compare coordinate B. Coordinate B has the coordinates 2, 3. Let's compare that to the corresponding vertice, which is coordinate D, which has coordinates of 4, 6. And so what I notice is that the x coordinate went from 2 to 4. The y coordinate went from 3 to 6. So what I'm noticing is the x and the y coordinates are 2 times bigger after the dilation. So after we dilate the shape, both coordinates got twice as big. So lengths of corresponding sides of similar triangles are in proportion. So are OAB and OCD considered similar triangles? So what we need to do is we need to find the proportion. Now, proportion means the fraction or the ratio. So let's find the proportion of OC and OA. OC over OA, 4 over 2 is 2. And then if we do the other proportion, CD over AB, that's also 2. So since the proportions are the same, these are similar triangles. So if corresponding sides are proportional, then we know the triangles are similar. So let's look at our bolded words here. So the transformation that we saw was considered a dilation. And a dilation is when the original and the image are similar. And so in the dilation, the ratio of the length of a side of the image to the length of the corresponding sides of the original is called a scale factor. So in the last one, our scale factor was 2 because everything was twice as big. So in this one, we are going to have a scale factor of 3. So that means everything needs to be 3 times bigger. So let's go through and do each vertice with a scale factor of 3. So this vertice is 2, 0. I'm going to actually just do my work here. 2, 0. If I scale that by a factor of 3, I need to multiply x and y by 3. So I get 6, 0. And so 6, 0 is right here. Let's do the next vertice. So this point is 0, 1. So if I scale that by 3, it's going to become 0, 3, which is right here. If I scale -2, 0 by 3, that's going to become -6, 0. And the last one I'm going to scale, oops, let me plot that first. And then the last one I'm going to scale is 0, -1. If I scale that by 3, that becomes 0, -3, which is right there. And so we can see that our shape stayed the same. It's still a parallelogram. It's just 3 times bigger, which would be considered an enlargement. So let's cover 2 vocab words. So the first vocab word I want to cover is similarity. So let's talk about what similarity means, what it means for 2 shapes to be similar. So to put it briefly, 2 shapes are similar if they are the same shape, but they're a different size. And so what we know about similar shapes is that the angles are going to stay the same. So the angles are equal. What changes is the corresponding sides. So the corresponding sides get either bigger or smaller. So what we say is the corresponding sides are proportional. Meaning if we do a fraction, they're going to be the same. So 2/3 is proportional to 4/6 because they're the same fraction. So this might be something that we see. The symbol for similarity is a squiggly, like that. So let's do 2 examples. So let's say I have this triangle that has a right angle, and then I have this triangle, which has a right angle. I'm going to try to draw it a little bit better. That's better. So both have right angles, and then the other 2 angles have to be equal as well for them to be similar. So we could show that by doing this. Let's draw that again. So this angle equals this angle, and this angle equals this angle. Those marks just show that those angles are equal. So if this was 30 degrees, this would be 30 degrees. If this was 60 degrees, this would be 60 degrees. But maybe the sides in the first one are 5, 4, and 3. And then maybe in the new one, they're 6, 8, and 10. So if I did corresponding sides, so 3 and 6 are corresponding sides. So if I were to do 6/3, that's equal to 2. If I were to do the next set, 4 and 8, I have to do 8/4 to be consistent. That's also 2. And if I were to do 5 and 10, 10/5 is 2. So these triangles are similar because their sides are proportional. I could also give you, let me try to draw that a little bit better. Triangles are not my friend on this. I could give you the same triangle, 2 right triangles with 3, 4, 5, 3, 4, 5. These are still considered similar, even though they're congruent. So congruent meant same exact shape and size. Congruent shapes are similar. Let's actually say all congruent shapes are similar, but not all similar shapes are congruent. So if you are given two congruent triangles, they have to be similar because their sides are proportional. But not all similar triangles are congruent, as you can see here. So a similarity statement is just a way to say two triangles are similar. So these two triangles are similar because their sides are proportional. So we could say triangle ABC is similar to triangle A prime, B prime, C prime. And so notice how I use the squiggle symbol to mean similar, and I make sure that it's going in the same order when I name it. I wouldn't do C prime, B prime, A prime if I wrote ABC. All right, last vocab word for today is scale factor. And so we talked about what a scale factor is. A scale factor is used, let me zoom in just a little bit here. It is used in dilations to change the size of a shape. Now there's two types of scale factors. There are enlargements. Enlargements happen when the shape gets bigger. If you have an enlargement, then I'm going to abbreviate scale factor as SF, just so I don't have to keep writing it out. So the shape gets bigger, the scale factor is greater than 1. So if the scale factor is 2, if the scale factor is 3, those are all enlargements. So the examples we saw already are enlargements. We also have what's called a reduction. A reduction happens when the shape gets smaller. In this case, we're going to have a scale factor less than 1. So if I had a scale factor of 1/2, I would get smaller. Or if I had a scale factor of 3/4, I'd be getting smaller. So let's do one of each. Let's do an example of an enlargement. And so it matters which is first, which is the original and which is the pre-image and which is the image. So if this was A, this was triangle A, and if this was triangle A prime, if these sides are 3 and these sides are 9, to calculate the scale factor, we do image, so the second shape, divided by the pre-image. And so the image was 9, the pre-image was 3, so my scale factor was 3. So that's an enlargement. If we went the other way around, if we did a reduction, and I had a triangle with sides, oops, no, that's not A prime, that's just A, the pre-image, 9, 9, and 9. And if my image got smaller, A prime was 3, 3, 3, then my scale factor would be 3/9, which is the fraction 1/3. So see how when I got smaller, my scale factor was a fraction less than 1. So if I look here, figure B is the scale copy of figure A. So we know that this is a reduction because I'm going from here to, I'm going from here to here and getting smaller. So it's not 2 or 3. So to figure it out, I'm going to do image divided by pre-image. So the scale factor is image divided by pre-image, 1 divided by 2, or I could do it the other way, 3.5 divided by 7. Either way, the scale factor is a half. That's the reduced form.